Hello everyone. I think remember in the last session we end with the topic FCU and AHU, right? Which is common for the different systems. In today's session, we'll deal with a very important topic, that is chillers. And for chillers, we have a separate part, that is a part 5. Okay, you see, I think remember we discussed the syllabus at the beginning of the session. So in part 5, we'll talk about this chill water pipe sizing, chill water pump selection, fittings, accessories, etc. So we have a separate part for this system. So that's the reason this system is very important. And if you talk about the big project or high-rise building, most commonly in actual practice, you'll find the chill water system. So that's the reason this topic is very important. And in this chapter 5, we'll discuss about the system, means about the chill water system, how the system works, means I'm talking about the concept, and about the pipe sizing, hookups, pumps, primary cycle, secondary cycle, expansion tank, air separator, insulation, a lot of things related to this chill water system that you'll find in part 5. You can find on the screen. So at this level, just try to understand the concept for this system, and this is very important. If you know the concept, then only we can think to deal with part 5, that is a chill water or HVAC water site systems. Okay, so the first you can find on the screen, you see chill water system. Under chill water system, here we are dealing with the chillers. Even district cooling system also comes under chill water system. Okay, so but commonly in actual practice, chill water system means people relate to the chillers, because district cooling system also a type of big chiller that we'll discuss after completing this. And if you know this chill water system, you can easily understand the district cooling system also. Okay, so here a chiller is a term used to describe a complete chilling package that includes, you see, multiple compressor. It can be one compressor or two compressor or more than that, depend as per the capacity. You will find multiple condenser. And remember, if I use the term multiple condenser, means I'm talking about air-cooled condenser. In water-cooled condenser, the type is different, in that you'll find one type, that is shell and tube. We'll discuss after learning this air-cooled and water-cooled, you'll get the clear idea. But if I use this term multiple condenser in chiller, means I'm talking about air-cooled chiller. At this level, don't get confused. Just let me complete this. This is just a beginning. So you see multiple compressors, multiple condenser, but only one evaporator. And you'll find the special type of evaporator in air cooled as well as in water cooled chiller. Or at this level, just I'm talking about the chiller. We'll discuss what is air cooled and water cooled next only. So if you talk about chiller, in that chiller you'll find special type of evaporator called shell and tube, or in other words I can say shell and tube heat exchanger, because the shell and tube heat exchanger can be used for evaporator or can be used as a condenser, and it's used in other applications also. Okay, so it's a type of heat exchanger. So what exactly or how exactly this shell and tube heat exchanger we'll discuss in the next page only. So you see, chiller is a term used to describe a complete chilling package that it includes multiple compressors because the capacity is higher, multiple condenser, but only one evaporator with the expansion also. Don't get confused. You will find the expansion device also, like the same vapor compression cycle, but the higher capacity. But the evaporator is a shell and tube type, and you'll find the internal piping and other controls. And you see on screen this image, you can consider this as a package chiller. And don't get confused with the package AC and this chiller. Package we used to call because all the components in one. But this is not the air side, this is the water side. For air side, again, we require the AHU. Okay, so in actual practice, you may heard this term package chiller, so don't get confused. I'm talking about the air-cooled chiller. Air-cooled chiller, we can consider as a package, because water-cooled chiller, we required the cooling tower away from the unit. Okay, so air-cooled chiller, we can also call as a package. So you'll find the internal piping and the heat exchanger. And this chiller will supply the chill water to what? To the AHU or FCU inside the building, and the hot water returned back to the chiller. But how exactly? We'll discuss in detail, because this topic I divide into different parts. You see, first we'll talk about what is chiller, just the basic. Then we'll discuss the types of chiller, the list. Then we'll talk about the types of compressor, because the chiller is classified based on the type of compressor also. Then we'll talk about in detail about the air-cooled chiller, how this air-cooled chiller works. Then we'll talk about water-cooled chiller, the components, and how this water-cooled chiller works in actual practice. Then we have a comparison between the air-cooled and the water cooled chiller, so that this comparison will help you to take the decision in actual practice as per the project requirement. So let me proceed. So on screen, you can find an image of air cooled chiller, also known as package chiller. And here below on the right side, this is a water cooled chiller. We'll discuss all these components, don't worry. This is just the preview for the air cooled and water cooled chiller. And you see the construction is totally different. Air cooled chiller is like a cabinet and we are placing completely outside the building. And this water cooled chiller, you can find out this is placed in the plant room inside the building, except the cooling tower. And what is cooling tower? We'll discuss. At this level, just I'm using some new terms and terminology. If you're not aware, don't worry. At the end of this session, you'll get the clear idea about this two types of chillers. So remember, this can be an interview question. First question can be what is chillers? And the second question is the types of chiller. So if they not add the type of chiller according to the compressor, in that case, they are asking about the type of chiller related to the condensing side only. So that there are two types of chiller. If you talk about the condensing side, one is a air cooled chiller and second is a water cooled chiller, commonly used in actual practice compared with the other types. Okay. So what exactly the difference between these two chiller? You'll get the idea after learning the cycle of both the systems. So first, let me proceed with the types of compressor. Because you see, in the type of chiller, you'll find the compressor classified based on the compressor also. Okay, so let me just read this at this level. If we talk about the types of compressor, sorry, my mistake, type of chiller. First, what we discussed just now, air cooled chiller. And in air cooled chiller, remember this point, we are using air to cool the condenser. How exactly? We have a topic. Yeah, so on the screen, you see, first is a air cooled chiller and the cooling medium is the air. How exactly we'll discuss. And second type of chiller is a water cooled chiller and the cooling medium for cooling the condenser is a water. And if you talk about air cooled chiller, you will find for small and medium type of project. Medium means, you see, chiller itself is for big project. Medium in the sense compared with the small projects. So I'm not talking about the villa or a small store. Here, air cooled chiller, if I use medium, in that also you'll find multiple floor building. Compared with the water cooled chiller. Water cooled chiller is for very big projects and it's offering the capacity up to 6,000 TR. That is a centrifugal type, very big system with higher capacity. So you see commercial, industrial and large application. This again I'll repeat after completing this air cool and water cool. At this level, just I'm going to read these different types so that you'll get the idea. The chiller can be classified as per the condenser and as per the compressor type. Okay. So further, you see scroll chiller. Scroll chiller means the chiller with the scroll compressor. Next, reciprocating chiller means the chiller with the reciprocating compressor. We'll discuss this again on this right side options. Next, we have a screw chiller, means chiller with the screw compressor. Next, very large, higher capacity centrifugal chiller, nothing but the chiller with the compressor of centrifugal type. And apart from this, the chiller can be classified as per the type of cycle. Most commonly in actual practice, you'll find the chiller with the VCR, nothing but vapor compression cycle, or else for industrial, you may find the vapor absorption cycle also. So these are the different types of chiller. If you talk about the classification according to the condenser, according to the type of cycle, or according to the compressor. So if you talk about compressor, again, that depends on the capacity also. We'll discuss the next only the type of compressor and the range for the compressor as per the type. And next, if you talk about the application point of view, mostly for residential, commercial, or even for industrial, you'll find vapor compression cycle. But vapor absorption, mostly you'll find for industrial application, not for the residential or commercial projects in actual practice. And if you compare this vapor compression with the vapor absorption chiller, the vapor compression chiller, the size is very small compared with the, very small means comparatively, the size of the vapor compression cycle is smaller than compared with the vapor absorption. Okay, so that's the reason generally you'll find this vapor absorption chiller in industrial side, not for the commercial or residential project. Okay. Next. So before moving to the air cooled and water cooled chiller, in detail. First, we'll talk about the types of compressor, because you see, air cooled chiller can be with a scroll compressor, can be with a reciprocating compressor, or can be with a screw compressor. Air cooled generally not with the centrifugal compressor, and water cooled chiller can be of any compressor. So if you talk about the classification according to the compressor, you'll find in air cooled as well as in water cooled, except this centrifugal compressor, not in air cooled. Similarly, if you talk about this cycle, vapor compression and vapor absorption, both you'll find in water cooled chiller, and most commonly vapor compression in air cooled chiller. So in actual practice, the if you talk about this chiller is majorly classified into two types. One is air cooled and second is a water cooled. Okay, so we'll focus more on that with more details, and you will get the idea about this cycle, how this chiller works, air cooled chiller and water cooled chiller. But before this, let me complete the different types of compressor. So if I show you the different types of compressor, that you can relate with the chiller, and you'll get the different types of chiller as per the compressor type. Hope you're getting my point. Yes, online?
Yes.
Next, you see at this level, just it's too early, but quickly let me give you the information. If you talk about the capacity for air cooled, start with 7.5 T. Now on screen, you see the capacity of the air cooled chiller is to start with the 7.5 to 600 as one chiller. Now, if you want say 1000 TR for as per the project requirement, one can use two air cooled chiller, or you can use multiple chiller of air cooled, say 600 into 3, so we can achieve 1800 TR as per the project requirement. But one unit in market is available up to 600 TR, more or less depend on application and the make also, but most commonly in actual practice, air cooled chiller is available up to 600 TR as one unit, and most commonly is available with the 15 TR, but even small chiller 7.5 also available, as depend again as per the location and make. Now if you talk about water cooled chiller, you see start with 10 TR up to 6000 TR as one unit, and 6000 TR means that higher capacity can be achieved only with the centrifugal type of compressor, not with the screw, scroll, or reciprocating compressor. So with the screw, scroll, we have a limitation up to 50 or 70 TR that you'll find in the next page only. Just for comparison, but we'll discuss how the cycle work and how exactly we can achieve this. This is just to get the idea, just for comparison. Chiller, air cooled chiller with a limited capacity, but water cooled chiller with a high capacity. I'm talking about one unit. With air cooled chiller also we can achieve 6000 TR with the multiple air cooled chiller with the complete circuit of pipe with the header. Okay.
One question.
Yes.
In actual practice, anyone is going to install for 7.5 tier air cooled chiller or water cooled chiller?
No, not commonly.
With the minimum.
Not commonly. Chiller generally for big projects. Okay. It's available for a small project as per the special application. But suppose one client is asking for chiller even for a villa, so we can use this. But the initial cost is going to be high, so you'll not find the small capacity chiller. It can be for a process control sometime. Small capacity chiller. That depends, but don't do at this level. Just don't do any conclusion, because in actual practice, the case is different. Next, so let me proceed with the type of compressor first before dealing with the air cooled and water cooled chiller. So you see, you can find on the screen, and this type of compressor you can find even for other systems except this centrifugal. Other system is in the last session, in the previous session, we discussed about the VRF or VRV. So most commonly in VRF or VRV, you'll find the scroll compressor. You'll not find the reciprocating commonly in market, because we have a list of advantage of scroll compressor compared with the other types of compressor. Or else even in window you will find this scroll compressor, or you may find the reciprocating compressor also. Okay, so we have some advantage and disadvantage of different compressor. But if you talk about the capacity, first you see here reciprocating compressor or scroll compressor, the capacity is up to 50 TR. Start with 1 TR to 50 TR. Next, for screw, up to 400 TR as one. But if you talk about centrifugal, you see 400 ton and more. Okay, up to this one, this chiller. Again, in chiller, you'll find the multiple compressors. So I'm not talking about one compressor with one chiller. As we discussed the beginning, chiller with the multiple compressors and the condensers. So in general, this is a range. So as a mechanical, I believe you know different types of compressor, but let me quickly play a small video so that you'll get more detail about this compressor. And here you see, if a chiller use reciprocating compressor, it can be air cooled or it can be water cooled, that we can call as a reciprocating chiller. Similarly, scroll, screw, or centrifugal. And for centrifugal, as I said, you'll not find in air cooled, you'll find in water cooled, because this is for industrial, for large high capacity, most commonly for this big projects, or it can be a industrial site, commercial large project, or industrial. You'll find this reciprocating type of compressor. Okay, so let me play a animated video.
D. The various types of air conditioning compressors used for cooling systems. In commercial air conditioning, the major compressors used are reciprocating, scroll, screw, and centrifugal. Compressor sizes start with reciprocating and scroll, thus the smallest, 3 to 175 kilowatts, followed by screw, 75 to 1,400 kilowatts, and centrifugal, thus the largest, 1,400 kilowatts and larger. Capacities listed are typical and may involve multiple compressors. Reciprocating, screw, and scroll are all classified as positive displacement compressors because the refrigerant chamber is actively compressed to a smaller volume. In screw and scroll compressors, this is a twisting or rotational action. In reciprocating compressor, it is the linear stroke of piston reducing the volume of the cylinder holding the refrigerant gas. The centrifugal compressor is a non-positive displacement type. It raises the pressure and temperature of the refrigerant by converting kinetic energy into pressure. Central plants usually have centrifugal chillers because of their large size. Screw compressors are most popular in the mid-size market and smaller, but they do not have the high part load efficiency of scroll compressors. Scroll compressors are becoming more prevalent in the HVAC industry. They have excellent reliability, high efficiency, low sound, low vibration, and better capacity control over a range of operating characteristics when compared to reciprocating and screw compressors of similar size. The Danfoss VLT HVAC drive has been engineered with a number of features to provide capacity control of scroll compressors through frequency control. Next, we shall have a look at the screw compressor operation. A screw compressor operates by using paired rotors machined to extreme accuracy of pitch and thread form to provide non-pulsating, positive displacement compression. Screw compressors have two precision machine rotors which rotate to compress the gas. Take a look at the illustration. It shows a male rotor and female rotor. As the rotors turn, the suction phase begins as a space opens at the top when the two rotors unmesh. As the rotors continue to turn, the interlobe space increases in size, and the gas is drawn in through the inlet port. The suction is sealed off by the meshing of the rotors as they continue to turn. In the compression phase, further rotation meshes the male and female lobes and reduces the interlobe volume. At a point, the gas is fully compressed and the discharge port is uncovered. The compressed gas is discharged and the compression cycle is completed. The typical capacity reduction method of control is a slide valve with a sliding action parallel to the rotor bores. They are placed close to the high-pressure discharge port and bypass a portion of the trapped gas charge back to the suction. This method of capacity control provides good part load performance without reducing the full load capacity. Next, we shall have a look at the scroll compressor process. Take a look at the illustration. It shows the mating and volute scrolls in a spiral shape that mesh. The upper scroll is fixed in place. An eccentric motor shaft moves the lower scroll in an orbital pattern within this fixed scroll on a rotor. In the compression process, the upper and lower scroll vanes form crescent-shaped pockets. As the lower scroll orbits, the sealing points on the vanes migrate inward, pushing the crescent-shaped pockets toward the center. As the pockets move, they decrease in volume and compress the trapped gas. Take a look at the illustration. It shows the sequence of orbits and the movement of the trapped gas pockets. In the first orbit, suction, as the bottom scroll orbits, two pockets of suction gas are formed and enclosed. Blue area. During the second orbit, compression, the pockets of gas are compressed as the volume is reduced. Green area. In the third orbit, the two pockets of gas are compressed further and discharged simultaneously through a small port opening in the center of the fixed scroll. Red area. With this, the scroll compression process is complete. Standard capacity control of scroll compressors is accomplished by installing multiple compressors in a single chiller to provide capacities of up to 175 kilowatts. Compressor volume control can also be accomplished by reducing the speed of the motor. The Danfoss VLT HVAC drive has been designed to provide speed control of scroll compressors.
Here, VLT is a name from the Danfoss. It refers to this VFD drives.
Next, we shall have a look at reciprocating compressor operation. Reciprocating compressors use pistons that are driven directly through a pin and connecting rod from a crankshaft, similar to an automotive reciprocating engine. The most important components in a reciprocating compressor are the suction and discharge valves. Suction process. At the beginning of the suction phase, the piston is drawn down in its cylinder, opening the suction valve, and vapor refrigerant is drawn into the cylinder. When the piston reaches the bottom of the stroke, the suction valve closes, trapping the suction volume. Compression process. The compression process is started when the piston is starting up the cylinder and begins compressing the gas ahead of it as the volume is reduced. Discharge phase. The discharge phase begins when the discharge valve first opens. As the pressure in the cylinder exceeds the pressure above the valve lifts, allowing the compressed gas to be pushed in the discharge manifold. The discharge process is complete when the piston reaches the top of the compression stroke and the discharge valve closes. There is always a small amount of clearance volume left at the top of the stroke to expend on the next suction stroke. Capacity control. The most common used method of control is bypassing the refrigerant gas with unloaders within the compressor. Next, we shall have a look at centrifugal compressor operation. Centrifugal compressors have long been used in larger water chillers. High efficiency, superior reliability, reduced sound levels, and relatively low cost have contributed to the popularity of the centrifugal chiller. The capacity of a centrifugal chiller can be modulated using inlet guide vanes.
See, actually, this is the compressor. This is completely water-cooled chiller. This is not completely chiller. Okay, in that compressor you will find here sorry, this is not completely compressor. Compressor is this part only. This is a water cooled chiller. We'll discuss next only after this animated video.
A combination of inlet guide vanes and a variable speed drive control are now being applied to new centrifugal water chillers. Existing centrifugal chillers must be studied carefully to determine if they can be controlled with variable speed drives. Using a variable speed drive with a centrifugal chiller may degrade the chiller's full load efficiency. Centrifugal compressors, sometimes called turbo compressors, continuously exchange angular momentum between a rotating impeller and a steady flowing refrigeration fluid. Because flow is continuous, these machines have greater refrigeration capacity than positive displacement devices. The suction flow enters the rotating impeller and is discharged radially at a higher velocity. A centrifugal compressor can be single-stage, having one impeller, or it can be multi-stage, having two or more impellers. The suction gas passes through a set of adjustable inlet guide vanes before entering the impeller. As inlet guide vanes open, more gas passes through the compressor. The vanes are used for capacity control, similar to inlet guide vane control of centrifugal fans. Capacity is varied by swirling the refrigerant entering the impellers. The inlet guide vanes produce this swirl. Setting the vanes to swirl, the flow in the direction of impeller rotation produces a near compressor performance curve without a change in speed.
So I think you got the idea, some idea related to the different compressor. For interview point of view, as I said, the important is air cooled and water cooled chiller. So we'll discuss in detail. But in order to understand this air cooled and water cooled chiller, first you must know this shell and tube heat exchanger, because in air cooled as well as in water cooled, you'll find shell and tube evaporator. And in water cooled, you'll find shell and tube evaporator as well as shell and tube condenser. So this shell and tube heat exchanger, first you must have the idea. This is simple. You can find on this image. You see why we are calling shell and tube. The outer one, this is section view. The outer one is a shell, this one, and inside you'll find the tubes. You see, these are all tubes. So here you see, for example, I'm using this shell and tube as, say, evaporator, for example. Or else, okay, we can take as a condenser, because you can able to understand this as a condenser easily, because you know the vapor compression cycle. So if I use this as a condenser, this is used to cool the refrigerant by using water. If I use this as an evaporator, then this is used to cool the water by using refrigerant. Okay, so in both the cases it heat exchanger, but it is going to be in reverse. So just try to understand in any one option. For example, you can consider as a condenser or evaporator. So let me show you this water in and out first. You see here, this red color you can consider as a hot H2O in, means hot water in. And this blue color you can consider as a H2O, this cold, H2O out. In as hot and out as cold. It means this shell and tube I'm using as a condenser. Okay, because this is used to, sorry, my mistake. This is used, I'm using this as a evaporator, because this is used to cool the water. Na? If I use this to cool the refrigerant, that case is going to be condenser. But in this image, since this inlet is red color represent hot and the cold color represent, sorry, the blue color represent this cold. So we can consider, as per this image, this we can consider this as evaporator. So water in from this and water out this, and the water is going to be circulate inside this shell, not in the tube. Okay, you see, and in the shell you'll find the baffles. Baffle is like this will guide the water. For example, if I remove these baffles, what will happen? The water will enter and it will create a lot of turbulency, and the baffle will provide that guide to the water. You see, here the water can go up, then down. So you'll find this path, so it can extract or it can exchange the heat efficiently. This is a construction for this heat exchanger. Okay, so water in and out in the shell, and you see, you can consider the refrigerant in as here, this is refrigerant in, and this we can consider as a refrigerant out. And the refrigerant will in the tube, and this you'll find here, you'll find a divider. The chill refrigerant will enter in these tubes, and you see here it may return and come out as a hot refrigerant. So this refrigerant is used to extract the heat from the water. Okay, so this we can call as a heat exchanger, and in this case this is a evaporator, because this is used to cool the water. No, simple process. So remember, in the shell the water is going to circulate, in the tube the refrigerant is going to circulate. In the normal case we have flooded type shell and tube evaporator also. In that case the case is going to be reversed, that is for higher capacity. But in most commonly in the chiller, air cooler and water cooler, except the higher capacities, in the shell you'll find water, and in the tube you'll find refrigerant, and this we can call as a shell and tube heat exchanger. Can be used for condenser, can be used for evaporator. And the same I'll show you in the air cooled chiller as well as in water cooled chiller. In air cooled chiller and in air and water cooled chiller, this we are using as evaporator. Plus in water cooled chiller, the same heat exchanger you'll find for condenser also. So I think you got the idea what is shell and tube heat exchanger. Next we'll talk about this air cooled chiller. First, till now what we discuss, this VRF system, the refrigerant is responsible to cool the air, but now in chill water system, the chill water is responsible to cool the air, and that water we are going to, from the water we are going to reject the heat to the refrigerant. Okay, that is a major difference between the DX and the chill water system. So here you can try to understand with the line diagram. I'll show you with the drawing also, but first some idea. You see, this is the air cooled chiller which we can place outside the building on the roof or outside the building. We cannot place inside the building because we are using this air cooled condenser. I'll show you some images to get the clear idea. So this is complete air cooled chiller, and this pump at this level we can call as a primary pump. In actual practice you'll find only primary or primary plus secondary, or you may find primary plus secondary plus tertiary for big project. That we'll discuss in part 5 in detail. At this level just I'm trying to explain the concept of air cooled and water cooled chiller. So this is an air cooled chiller, and this you can consider as a chill water pump primary, and you can consider this is AHU1, AHU2. Forget about this boiler. In that you'll find the heating system also, that we'll discuss later. At this level just we're focusing on this chiller. So you see, from this chiller the chill water is going to circulate and supply in what? Cooling coil of evaporator. And this evaporator can be inside the AHU or can be inside this FCU to cool the air. Further with more details, let me open one drawing. With that you can try to understand the clear concept. But before this, let me show you some images. You'll get the idea. This is an installation of a chiller with a crane. Belongs to a Oman project. They're doing the preparation and all. You see in this, the above one, these are all condenser. You see, this is air cooled condenser. You can find the fins inside. You'll find the tubes, and this is shell and tube evaporator, and you'll find the expansion, and other side you'll find the compressors also. You see inside this cabinet you'll find the compressor. I'll show you the closer view. And this is a foundation you need to prepare before installing this chiller, and in between the foundation and the chiller will use the isolator also to reduce the vibration. Some additional points related to installation, but at this level just try to find out the different components of the chiller. Now you see here in this chiller, here 3 cabinets, here 3 cabinets, so total 6 compressor, and in between this is a electrical control, and above that you'll find all condenser, and on the top you'll find the fan. So with this construction you can find say air cooled chiller, and we are placing outside, because in water cooled chiller you'll not find the fans. In air cooled chiller only you'll find the fan, because The major difference between air cool and water cool is the condensing side only. Okay, we'll do the conclusion at the end. Let me proceed. You can find the closer view of the fins. Inside you'll find the tube. So this is a coil heat exchanger for condenser. And you can verify the fans also from the top view. These are all condenser fan used to cool the condenser. And you know the vapor compressor cycle, the same cycle, but the construction is different. So let me open one drawing to understand this cycle on screen. You see, in chiller you'll find two cycle. At this level I'm talking about air-cooled chiller. In air-cooled chiller you'll find two cycle. One is a primary cycle and second is a secondary cycle. And inside this chiller, you see this compressor. These are all multiple compressor, and here added one condenser, but you'll find the n number of condensers, an expansion, and a shell and tube evaporator. Okay, and this complete we can call as a primary cycle or refrigerant cycle. And you already are aware of this. I'm talking about vapor compression cycle. But in chiller, we used to call this as a primary cycle because in chiller, you will find the secondary cycle also. And this piping, you see, from the chiller, you can see the direction of water. You see, chill water out and this chill water return. So this cycle we can call as a secondary or chill water cycle. And you know the primary cycle is of copper, and that will take care by the vendor. But if you talk about the secondary cycle, as a HVAC engineer, your role is to design this pipe size. I'm talking about the chill water pipe sizing. And the secondary cycle is of carbon steel. And under carbon steel, you'll find black steel, low carbon steel, or mild steel. Okay, so most commonly in actual practice, in India, you'll find mild steel MS pipes. In Gulf, you'll find black steel of schedule 40. Remember, this is a class of the pipe. We'll discuss more about this in part 5. At this level, just I'm focusing on the cycle, and this also with insulation. I'll show you the preview of this piping also, but let me complete this concept. So you know the cycle, vapor compression cycle. After compression, the refrigerant will enter in the condenser and the expansion. Then it will enter in shell and tube. What in this case, shell and tube evaporator. And what will happen inside the evaporator? Just now we discussed now. So refrigerant in what? Refrigerant in as chill refrigerant, refrigerant out as hot refrigerant. Okay. And you see the direction of water. This is what? H2O in. And this is H2O out. And if you talk about standard temperature, remember the chill water in most or almost all manufacturer catalog, you'll find the standard 54 degree Fahrenheit, and chill water out is 44 degree Fahrenheit. Apart from this, you may find this 50 degree Fahrenheit also as a chill water temperature, but in present market, if you talk about the standard chiller, you'll find this 44 degree Fahrenheit, nothing but we can consider in between 6 to 7 degrees centigrade is a standard temperature of chill water. And based on this, we have the conversion like 1 TR equal to 2.4 GPM. We'll discuss about this at this level. Just remember this point. Now, you see this water in as what? Cold water. And what will happen? Circulate on the coil and loses the heat. And out as what? Is online?
Cold water.
Yes, out as a chill water. So you see, I use the term cold and chill. So we are not using the hot. We can consider the hot also, but it's not a very hot or a boiled water. So we used to call cold water in, or this in actual practice we used to call chill water return and chill water supply. So this line, for example, if I write some points, you see I'm considering this as say 0.1, this I'm considering as 0.2, this is 0.3, and say this is 0.4. So remember 0.1 to 2 is what? CHWS, chill water supply. And 0.3 to 0.4 we can consider as CHWR with respect to the system. If we talk about the chiller, this line we can call as an inlet, and this we can call as a supply to the chiller. So if you talk about the equipment, the case is going to be different. Here I'm talking about the supply return as with respect to the system. Okay, so with respect to the system, the supply to the chiller comes under return line, and supply from the chiller comes under supply line. Remember this at the time of pipe sizing. Also, we need to identify this direction. Next, so you see in as a cold water loses the heat to the refrigerant, out as a chill water, and this chill water with the insulated pipe is going to supply to one more heat exchanger inside what? AHU. And you know what is AHU? Or it can be AHU or it can be FCU as per the requirement. And in actual practice, you see in this drawing, you'll find one AHU, but you see the pipe will continue and can connect to n number of FCU or AHU as per the capacity of the system. Okay. So you see this chill water will enter in cooling coil of AHU. And you know what will happen in AHU and this air site? Same like a ductable split. Instead of connecting this pipe from the condensing unit, we are connecting the pipe from the chiller to supply the chill water instead of the refrigerant. So rest of the thing inside, you know, we can provide the fresh air. All this detail you can consider same like a ductable split, what we discussed, like call piece, then supply return, etc. Okay, and you see this, the cooling effect or the heat will extract from the room air, and the hot water, or we can say chill water return from this point 3 with this pump, and pump is used for what? To circulate the water. And in this case, this we can call as a primary pump, because this pump is used to supply the water to the chiller. In actual practice, you'll find the pump set here that we used to call as a secondary pump. That story we'll discuss later. We have a, as I said, now this is part 1 of this system. The detail of this you'll find in chill water system. Chill water system I'm considering as part 5 of the syllabus now. Okay, so at this level, wantedly, I'm not explaining these options to avoid confusion, because if you know the system, if you know this concept, then we can think for the remaining in detail with the expansion tank, air separator, a lot of things with all hookups, nothing but valve package with more details. So you see, this pump is used to supply the water back to the chiller and the cycle continue. So this is about the air cooled chiller, and why we are calling air cooled chiller. Remember, we are cooling this condenser by using the air. That's the reason this system or this chiller we used to call as air cooled chiller compared with the water cooled chiller. In water cooled chiller, the condensing unit we are going to cool by using water, and water we are going to cool by using cooling tower. So you'll find one more circuit in water cooled chiller that I'll show you next. But before this, any confusion in this cycle online?
No, it's clear.
Yeah, apart from this, you see this civil foundation, nothing but base is required to construct, and the dimension of this base you can find out from the shop drawing. And the shop drawing means, you know, at the time of construction, means at the time of installation. And so the actual dimension of this foundation you can find out from the catalog of the manufacturer, and the same will follow in the shop drawing. Based on this, we'll construct. And before installing the chiller, or in between this base and this chiller, you'll find this spring isolators to cut the vibration, because in that you'll find the multiple compressors, so chance of transferring the vibration to the slab, and it's placed on the roof, so it may transfer the vibration and create noise, and it may affect to the strength of that structure also. So we require the spring isolator. 1 minute, I think I have an image for this. Here my example of a spring isolator. This is used to reduce the vibration. Not only for this, even for AHU or for ceiling suspended AHU, floor mounted AHUs, you'll find this isolators, which is required to cut the vibration. Next, we'll talk about this water cooled chiller. You see the additional components in water cooled chiller. In water cooled chiller, this chill water cycle is same as air cooled chiller, but in water cooled chiller you'll find 2 shell and tube. One is for evaporator and one is for condenser. And if you talk about evaporator side, the cycle is same as air cooled. So let me show you some images first. You see this like a complicated machine. Can you identify this 2 different types of shell and tube heat exchanger? Here heat exchanger, this is 1 shell and tube, and this is one more, 2 shell and tube. And you'll find this multiple compressors, find the expansion. So same components, compressor, condenser, expansion, and the evaporator, but the condenser as well as evaporator both is of same shell and tube type. Now, can you identify which is condenser and which is evaporator in this image? Any guess?
Below one white,
It is condenser and back.
white
Remember, we have a simple clue for this. Always the insulated heat exchanger is a evaporator. So you can find the insulation, the black insulation on above. So this is evaporator and this is condenser. And with the cycle also you can identify, you see after compression, this the pipe is connected to this heat exchange. So this must be the condenser. Apart from this, this green color pipe, most commonly in actual practice, this is for cooling tower. One is from the cooling tower and one is to the cooling tower. So with the different options you can identify, but without this piping also, easily you can identify the insulated shell and tube is a evaporator. And the reason, because in evaporator, you will find this cooling effect. No? So to avoid this energy losses, we require insulation for the evaporator. But for condenser, we don't require the insulation because this rejection of heat will add advantage. So you'll find two shell and tube. And because of this, you'll find three cycle in this. One cycle is what? The vapor compression cycle. Same. Compression, condenser, evaporator, expansion, you know all this. The second cycle is a chill water cycle, same as air cooled. And the additional cycle in this is what? Condenser cycle, which will connect to the cooling tower with a separate pump. And why the need of this cooling tower? And how to cool the water which is used to cool the refrigerant. That I'll show you with the line diagram. Before this, some more images. You'll find the controls, you'll find the electrical panel, lot of things. And this the control and the valves and other details is very, very important. We'll discuss at the time of part 5 under the topic hookups or valve package. At this level, just I'm showing some preview of this. This pressure gauges, there's different valves. This is very, very important for interview point of view and for installation as well as for designing point of view. Designing point of view for pump selection, because all these accessories and the fittings will create a higher pressure drop. So that must consider at the time of pump selection. So as a design engineer or as a installation engineer, for both these accessories are important. So we have a separate detailed topic in part 5. So at this level, just we're learning how this system works. Okay, so let me proceed. We'll try to understand with the drawing. First of all, with this image, what are the additional components in this? First of all, this green color line is a condenser piping. So additional cycle you'll find. And this cycle from the chiller is connected to, you see, it's a cooling tower. And cooling tower is simple construction. Cooling tower is used to cool the air. And the concept is evaporative cooling, like air cooler. How exactly the cooling tower, that also we'll discuss. But you see, this water which is used to cool the refrigerant is going to cool back by using this condenser, and for that we require a separate cycle and separate pump. So this complete circuit is a condenser pipe with a separate pump. Apart from this, we require the makeup water tank also, because you see in the cooling tower, continuously the water is going to evaporate because the hot vapor, the cooling tower is used to separate the hot vapor from the water, like in air cooler. So you see in air cooler also we required the supply of water. No? After 1 or 2 hours, the level of the water decreases. Why? Because the water get evaporates. And evaporation means it will take the heat from the air. But in this case, it will take the heat from the water, which is going to collect at the bottom. Nothing but evaporative cooling. So it will separate the hot vapor from the cool water. So let me show you with the line diagram. Here you see this side, this cycle is same as air cooled. What we already discussed. The secondary cycle is same in air cooled as well as in water cooled. But in water cooled, you see, you can consider this H2O in, and we can consider this as a cold water in, and out as what? The hot water out. Okay, and this water is responsible to pick the heat from the refrigerant, and you can see from the compressor, the refrigerant is entering in the tube in the shell and tube heat exchanger, and water in as a cold water. I'm not talking about, I'm not saying chill water. Chill water you'll find in this side. Here the cold water, which is used or which you can get from the cooling tower. Okay, so cold water in and extracting the heat from the refrigerant. And if you talk about the standard temperature for this cold water in, this is 81 degree Fahrenheit and the return is 90 degree Fahrenheit. Okay, so you see that the difference is nearly 10 degrees. Even here in the supply return also, suppose 54 and 44, the delta T is going to be 10. And remember, this delta T will use at the time of pipe sizing. And based on this, for this side, we have conversion 1 TR equal to 2.4 GPM. This is just a preview, just remember this. And for this side, we have 1 TR equal to 3 GPM. And why this difference in the flow rate? I'll just give you the idea. The detail we'll discuss in part 5. Because you see, here in this heat exchanger as evaporator, we are using refrigerant to cool the water. And in this case, we are using water to cool the refrigerant. Okay. So to cool the refrigerant by water, we require higher flow rate because the specific heat of the refrigerant and water is different. No? The specific heat of water refrigerant is more compared to water. So if you use water to cool the refrigerant, we require more flow rate for cooling the refrigerant compared with the cooling the water by using refrigerant. This is one point. We have some more points. We'll discuss this more about this. At this level, just remember this conversion. So you see the hot water, again, in order to use again this hot water to cool the condenser, it will supply to cooling tower. And in cooling tower is going to be supplying the sprinkler form. And on the top, you'll find the fan. And you see fan will suck the air from here. And the air communicate with the water. And the hot vapor is going to separate from the cooling tower. It's allowing only the cold water to collect at the bottom. Nothing but evaporative cooling. Okay, so continuously the cooling tower is used to separate the hot water from the return line from this cylinder tube condenser and allowing this cold water at the bottom. And again, this cold water by using this pump, and this we can call as a condenser pump as per the cycle. Okay, and this is a primary pump or chill water pump as per the concept. Primary, secondary we'll discuss later. This is a chill water pump and this is a condenser pump. This condenser pump again used to circulate the water. And you see, continuously we are going to evaporate. We are going to separate the hot vapor from the water. No? So what will happen? The level of water will decrease. So we require the make a water tank or a supply from the plumbing float valve. Suppose if I'm supplying from the municipal from the lower level, we require anyhow float valve is required. So float valve you find the tank as the water maintain the level, it will close. Anyhow, the detail we'll discuss later. So we require a make up water also to maintain the water level. So it means compared with the air cooled, the water cooled chiller required continuous supply of water, right? And in case of scarcity of water, we cannot use this water cooled chiller. And this is one difference. We have other points also to discuss. Okay, so the cycle continues. So in this, you'll find 3 cycles. One is a refrigerant cycle, second is a chill water cycle, nothing but secondary cycle, and the third is a condenser cycle in water cooled chiller. And for interview point of view, remember this is important. First question, they may ask what is chiller? Different types of chiller. The second question is different type of chiller. And the third question can be the difference between the air cooled and water cooled chiller. So got the idea, the difference between air cooled and water cooled chiller. So the difference is at condensing side, na? Rest of the thing is same. The primary cycle is same. The refrigerant cycle, this secondary cycle is same. But the difference is only at condensing side. So this is important. So for interview point of view, you must use this term condenser. In air cooled chiller, the condenser is cooled by using the air, means the outside air. And we are placing that unit completely outside the building. And in water cooled chiller, the condensing unit is cooled by using water, and the water we are going to supply back from the cooling tower. And remember, this complete unit we can place inside the building except the cooling tower. Okay, because cooling tower we cannot place inside the building because this is used to separate the hot vapor from the water. No? So except cooling tower, the complete unit we can place inside the building, and that we are placing in the plant room. And cooling tower can be placed outside the building or on the roof. But if you place the air cooled chiller on the roof, we can expect higher efficiency because air cooled chiller, the condenser is cooled by air, na? And if we place on the roof means as the wind velocity is higher on the roof, the condensation efficiency will improve. Or else in the open area, we cannot place in the closed areas. I'm talking about air cooled. Air cooled we cannot place in the closed areas or in the area with the limited wind velocity. If you place in the rooftop or in the open area with the high wind velocity, you can expect the efficiency. But under that also we have some condition. If the outside temperature exceed 40 degree centigrade, again the efficiency will drop. That we'll discuss at the time of the difference between air cooled and water cooled in this chapter 5 only. One more point, you see, this is also important point. For example, compare this chiller, for big project, if you use DX system, you need to supply the refrigerant for the entire FCU and AHU,
Yes.
and compressing that much of refrigerant required very high capacity compressor. Compare with circulation of water,
Okay.
because water remain water only in the entire circuit,
Yes.
but refrigerant changes phase from gas to liquid and liquid to gas, and compression required. And compared to compression, circulation required less energy.
Yes.
Circulating water required less energy compared with the compression of refrigerant. Okay, this is also one point, but we have other points also to discuss. Yeah, can I proceed to next?
Yes.
Sir, regarding it is not relevant at this time, but when we are using the cold storage, at that time we are using this ammonia refrigeration cycle, and some I think chillers are used. At that time, the minimum temperature will not be more than 0 degrees Celsius when we are using the water.
Yes, no, it can be, because we are using a brine, not only water. We're using brine solution, water mixed with the glycol or propylene. We have different chemicals, and that solution we used to call as a brine solution, and
Okay.
with that we can reduce the freezing temperature of water to -4 or less than that.
Okay, means still in ice manufacturing they are using the brine solution.
Yes.
Okay.
Even in this also we are using, in this cycle also we are using this for n number of reasons. We are not using the normal water. We are using water with the glycol or propylene that we used to call a brine.
Even in air conditioning also.
Yes.
Means okay, glycol has that capacity to hold the temperature for more time, na?
Again, apart from this, for life of the system, if you use only water,
Okay.
like you see, normally in our car radiators we are using coolant, not just water.
Coolant.
But you
Yes.
see, coolant we are using to increase the life of that heat exchanger. But the coolant is not used to extract the heat. The water is responsible to extract the heat. Okay, if you use pure coolant in the car, that will not help to reduce the heat of the radiator. Water is must. With the water, partly coolant is required, so that the coolant will help to not to damage that system.
To reduce the oxidation.
Yes. Okay. So next difference between the air cool and water cool. This is important for interview point of view also, and this will help you at the time of taking the decision. But you see, if you are a beginner, or if you are means even experienced, you're not supposed to take the decision in actual practice. In actual practice, this decision is going to be taken by the senior mechanical or architect, or the means in the meeting at the initial stage. But this point will help you to suggest the time of at the initial stage of the project. Okay, and mostly this chiller system we are using for big project, not for small project. Can be used for small project, but generally you'll not find this, except the special cases where the client is very much bothered about the running cost, or based on the availability of the system, etc. Okay, so we have some important points to discuss related to the air cooled and water cooled system. Apart from this, you see one more point related to this water cooled chiller. We require this dosing plant also if required, if the water is not the potable water. It means a separate treatment is required to maintain the quality of the water, so that it will not decrease or damage the system. Okay, in some
I mean,
projects,
we need soft water, right?
pardon? Soft water plant is required, a dosing plant. If you are getting a hard water in your location, then to convert into the soft water, like 2000 this TDS level is we can consider as a hard water. So to convert that hot water into soft water, a dosing plant or a softener is required. Or else what will happen, the life of the system will reduce. This also one disadvantage, but we have some more points. You see, this is important for interview point of view. You see in the list, the first point, if we talk about the difference between air cool and water cooled chiller, cooling medium you see we are using the atmospheric air in air cooled chiller. There is a major difference between air cooled and water cooler. In water cooled chiller we are using water. to cool the refrigerant. Next heat rejection, release heat to the atmosphere, and here release heat to the cooling tower or to the water, which is used to cool that condenser again. Next, condenser fan you will find in air cooled, not for the water cooled. Cooling tower is not applicable for air cooled, is applicable for the water cooled. Water usage, typically low water consumption, because you see in air cooled chiller we require to fill the circuit one time. And apart from this, a small makeup water tank is required even for air cooled chiller also. Because see, some amount of water is going to come out from this air vents, automatic air vents, but very less compared with the water cooled chiller in cooling tower. Okay, so the consumption of water in air cooled chiller is very less compared with the water cooled, and continuous required of water in cooling tower in water cooled chiller. So if there is a scarcity of water, or if the water is expensive in your area, then we are not suggesting this water cooled chiller. We are using air cooled chiller only. Okay. But if you talk about efficiency point of view, that depends on the condition. For example, you see first here in this case, slightly less efficiency compared with water cooled chiller. Here typical more efficiency due to the higher heat capacity. This is in general, because the density of water is much higher than the air. So water extraction, water heat extraction compared with the air is 4 times higher. Okay, so efficiency point of view, you can consider water cooled chiller is offering higher efficiency. But if the outside temperature throughout the year, say less than 35 degrees centigrade, in that case, air cooled chiller is more efficient. You see, the outside temperature is suppose take example of Bangalore or many cities in India or in Gulf. Not many cities in Gulf, but in Gulf also you'll find some cities the temperature throughout the year will not exceed more than 35 degrees centigrade. In that case, air cooled is a best choice. Why? Because air cooled chiller work efficiently when the outside temperature less than 35 degrees centigrade. If you exceed more than that, say 40 or more than that, in that case, what will happen? The extraction or heat extraction capacity by the air is going to reduce because we are using air to cool the condenser. If the outside air is hot, what will happen? The efficiency or the heat extraction reduces. In that case, water cooled chiller work efficiently. Okay, so this is also one major point to consider at the time of selection. If the outside temperature throughout the year less than 35 degrees centigrade, air cooled is the best option, or else you can suggest for water cooled. But that is not only one point, because in some cases the outside temperature is above, suppose it's 40, 45 or more than that, but the scarcity of water, in that case there is no choice for the water cooled chiller. You need to compromise with the air cooled chiller. But if you have both the in that case, you can take the decision accordingly as per the condition. Okay, now if you talk about maintenance, you can think air cooled chiller, the maintenance is very less compared with the water cooled chiller, because water cooled chiller cooling tower, and this cooling tower we are using, which is placing outside the building, and deals with the potable water. So water means the chance of corrosion, and the cleaning is required. And this cooling tower, all these components, so proper maintenance or regular maintenance is required compared with the air cooled chiller. So maintenance point of view, you'll find more maintenance in water cooled compared with the air cooled. Next, space point of view, depend again as per the case. Water cooled chiller required space inside the building and partly outside, and air cooled chiller required space outside the building. So as per the type of project, if you have enough space inside the building, we can go for this water cooled, or if you have enough space outside the building, the choice can be this air cooled. Okay, next, noise level may produce noise due to this condenser fan. I'm talking about the air cooled, and in some cases this noise may create disturbance to the other building, the neighbor building may be a high class building, or some government buildings, or some authority. So in that case, there may be chance of objection, so you need to consider that. But water cooled, since it's inside the building, I'm talking about cooling tower. Again, cooling tower will create noise. I'm talking about this water cooled chiller inside the building, so in the plant room. So noise point of view, it will not affect to the neighbor building. Initial cost, obviously, for water cooled is going to be higher, You see, typically less initial cost. I'm talking about air cooled and water cooled, not compared with the DX system. So air cooled chiller costing is less compared with the water cooled, because you'll find the additional cycle in water cooled system. Application point of view, as we discussed at the beginning, this centrifugal compressor available with the water cooled chiller only. So for higher capacity requirement, we'll go with the water cooled, but for medium or large capacity, we can go with the air cooled. You see, commonly used for smaller to medium size application, and this smaller and medium compare with the water cooled, not compare with the DX system. Okay, small means don't think that I'm talking about a villa or a small office. Smaller or mid size compare with the large commercial or large industrial site. Water cooled, you see, for large size application and industrial process. Next, location flexibility, suitable for location with the limited access of water. As we discussed, if the scarcity of water, the choice is going to be air cooled. If if the water is available, then the choice can be a water cooled chiller, considering the other parameters. Next, if you talk about environmental impact, again, this water cooled chiller, consumption of water compared with the air cooled. So air cooled is a good option if you talk about this saving of water. Next, efficiency, as we discussed. You see, efficiency may decrease in extreme hot weathers, but you see, even the outside condition is higher in temperature, like above 50 also, the water cooled efficiency of water cooled chiller efficiency is going to be good, because water remain water only, even above 50 degrees centigrade. But air, if the temperature increases, the air temperature also increases, the efficiency of the condensation decreases. The same point what we discussed. Okay, so there are some important points or comparison between this air cooled and water cooled, and important for interview point of view also, and this will help you to take the decision as per the project requirement. Now, if you talk about the capacity, you see, as we discussed, 7.5 to 600, you one unit for air cooled, but for water cooled up to 6,000 as a single unit. And the quick summary, you see, generally we are using air cooled when the energy costs are low and the water cost is high. This is one point. You have we discussed the other point also. And if we talk about water cooled, when energy cost is high and water cost is low, the water cooled we can suggest water cooled. So this is about the air cooled and water cooled cycle, just a cycle, but we have a separate part for this. In detail, we'll discuss about the other components and the accessories and the chill water pipe sizing, etc. completely in this part 5, you see, after completing this 8 side ducting. Pump selection also comes under this pipe sizing, chill water pipe sizing, hookups, etc. At the time, we'll get more detail about this. But if you know this concept, then part 5 will be easy for you, because in part 5, we are talking about this chill water side only. So done for tonight online.